Yeah, thanks. I have also problems pronouncing, so it should be like 77FEH. And we will learn what it is and how to get the access to it. What I'm talking about is actually I will talk about physical access to such devices, what can be done, but also from the hyper world, what can be done in this case. And I will talk about, let's say, vulnerabilities, or maybe better, something like lack of protocol design, and the exploitation of these things, and what can be done to actually remove these things from there. And also, if there's any questions and answers, it will take like 30 minutes. So in short, what I'm talking about is, I'm talking about these devices. And these devices are actually very small devices. Usually when you will not just go to the shop and buy it. Probably if you are some kind of embedded vendor, then you will probably go and buy a lot of these things and embed it inside different devices. So it's more like you can find them in almost every aspect of different embedded devices. So you can find them in alarm devices, you can find them in HVAC control system and so on, pool monitoring systems if you are rich enough to have pool, sprinkler controllers and so on. So it's really from different small embedded devices to the real big industrial systems. You can find them, especially on the custom ones. And why? Because usually embedded hardware vendors just use one let's say interface, and it's usually serial, and then they decided, oh, I want to go to the IP. And once they decide to go to IP, they just don't want to spend so much time implementing their own TCP IP stack and so on, so they just use some ready-made system. And Lantronix is one of them. So they just connect on the one side serial port, and Lantronix just provides you Ethernet port, and then you can control that device as well. So since on Balkan we talked about security of cars, industrial SCADA systems, which Alexander talked, and so on. So I guess we just missed those pool monitoring systems, alarms, and so on. So this is that talk. So I'm really I have one here. So it's really just this part, right? So I'm talking about this part, and it's a really small one, but it has a TCP IP stack inside, and what it allows you is actually allows you to access what this controls, to actually have access to the control system, or to read the readings and so on. But what's most interesting, for example, for alarm systems, you can get the access to the control of alarm system itself. So if you ask, okay, what these small things are running, it's actually, they're mostly running COBAS in smaller versions, that special operating system. And in some bigger systems, they also, of course, run Linux and Tradix or something like this. And you can have like more serial ports. This is just one small version which I showed you. This one is for alarm systems. So you just have one like serial port, and on the other side you have Ethernet port. And some of them are actually supports like Modbus and that industrial protocol, and also like you have now gigabit connections as well. But the problem with those devices is they don't get upgraded so frequently, so that's the problem. So if you have physical access, yeah, you have no password by design. So if you just connect with standard ATL cable on the serial port with bus pirate or whatever you have, you can just get the shell right on the side. So this is just how you do it. This is how it looks in theory, and this is how it looks in practice. And then you have the access. So this is not a big deal. You can actually just read it in documentation that this is by design. But if you look from the IP side, they usually provide such services. They have like a web service where you can configure the device, how it handles that serial port to the embedded device, the speed and so on. You also have like telnet administration interface to actually administer it over IP. And you have also something called like something listing on 30718. And also you have SNMP to actually ping it if it's still alive and get some useful information. And if you're lucky enough, I wasn't lucky at my engagement, you have also like TFTP, which is like for firmware updates. And this is where you can actually get updated the firmware, right? So the idea is actually, oops, let me see. So if you want to actually discover these devices, you actually look for these specifics, right? You look for that specific ports. If you're doing passive doing passive sniffing, you just look for these specific ports, right? And if you're doing actively, you actually scan for these ports and try to find it. The other thing is, of course, you can always ask and use the social engineering, and then you know where it is. But the problem is usually same as embedded systems or same as, let's say, some industrial systems. They are kind of fragile and they are not big. So if you do something like vulnerability scanners, you will just misconfigure the device. I will tell you later how it looks like. So once you connect to such device, you actually get, for example, for telnet interface, you just get something like this and yeah, go away, right? You try to type something standard passwords like root, admin, and so on, and then, right? But let's answer that. So what that port is, which actually looks strange, right? So this is something I'm talking about today, is about 77FE port. And that device is actually using it for some kind of administration and configuration besides telnet. So it's kind of proprietary protocol, and it's used by the device installer, which is kind of proprietary tool to actually find these devices and configure them. So it's like interesting port to actually tackle, right? So this is how it usually looks like. You just send something, you send some kind of commands, like this is for device discovery, you send like F6, 00F6, and then you get something like device type here, right? And it's pretty simple protocol inside. So you can actually just, since it's UDP and TCP, that means you actually can send a broadcast packet and get the answers, and then just look up from all the answers and do the protocol, do these devices identification very easy, finding them. So yeah, this is the query setup. This is, you get the response, you get the MAC address of the device, and you get the device type. So the protocol is kind of easy. And there is actually one request where you actually say, give me your setup, right? You get the same, but what you have is you get the simple password in plain text. So if you cannot get the access to the telnet interface, you just go to this port and ask, oh, what's your password? And it tells you, right? And what you can see, it's fixed record. So that means four characters. It's maximum length of the password. But this is actually already done. And there were some previous people who already found out about this problem. And they said, okay, this is what you can do. And this is the Rob Winston who done some of the work and the Metasploit modules and so on. And Igor as well. But the problem is, I get that password, and it's actually disabled. Disabled means the password is all zeros, like null bytes. And I'm still getting the password prompt. So, oh, this is interesting, right? The simple password is disabled, but I still get the prompt. So once I start digging, I actually found out that there is something called enhanced passwords. And you cannot just get easily like get or set enhanced password like before, right? And the length is bigger. So that means sounds like challenge, right? And if you look at the documentation, yeah, they really like made it better. Like they made like 16 characters password, and you cannot see it in query setup just to get passwords, right? But of course, this sounds like a challenge, right? And when I started digging around, because I had like some kind of previous work, so I could see at least for the basics of the protocol, so I tried to reverse the other parts of the protocol and found out if I can find something what I can actually use to see if I can get the enhanced password. So one of the interesting requests is actually get like extended version requests. This is something what is called, and you get the version, but also you get sometimes single password in plain text. It actually leaks some part of the setup, and it depends what previous request you've done. But playing with this, it actually didn't get me anywhere. I could just get a simple password anyway, so this wasn't the right way. But still, you can get some parts if you query different like commands, and every time you ask again for this extended version, you always get the different here results, and it really leaks sometimes useful information. And further digging, I actually found out that you can actually query configuration, like you have like a lot of setup records. So you just send like what setup record number you want, and you will just get it. And well, this sounds like quite easy, but it's actually problematic because security record is number one, and if you ask for it, you just get the 0 bytes, and that's where the enhanced password is. But there is actually that security record one. You also have like AES key. Yeah, that small thing have actually like encryption. So if you talk to that embedded device, whatever it is, it will actually you can have it encrypted. And when I ask for it, I just get 0 bytes. So that means, oh, you don't have access to it, right? But so that means it's half interesting requests. You can get the other configuration and so on, but the password you cannot get. But the other thing is you can actually change configuration, and this is actually interesting. You cannot get the password, but you can reset it. If you just change that setup record number one, you can just set the password that you need, right? So how it looks like, you just send like, okay, I want to set up record one, and you have to know where the password is. So for example, in this case, if I want to just reset the password, I just send zeros. So enhanced password will not be enabled. And the other thing, I just have to know the other fields where they are. For example, where the SNMP community string is and so on. So this is actually a way to actually reset the enhanced password. And what you get as a response is, of course, just, yeah, I've done it.
Does that reset the AES key?
As well, yes.
Okay.
But there is also further digging. Further digging actually found out that you can actually, if you want, there is also a way to reset everything else beside AES key, and you can also reset just whole record. So that means you can do the both ways. And once you send such request, you actually get, oh, this is, we don't have any password, so just enter the site, right? So what I found out is by looking at the dump and at the protocol as well as the firmware, this is how the algorithm looks. Okay, if it's authenticate, if it has enhanced password, ask for enhanced. If it doesn't set, you just use the simple password and ask for simple. And if everything is resetted, you just display the setup menu. And this is how it looks like, yeah. So I implemented a new tool which actually used these old tricks mentioned. So what it does is actually gets you the simple password. If it doesn't work, it will get you the enhanced. It will reset the enhanced password. It will It will get you all the dumps of the setup records, and also what it will do is it will actually try to request different requests with the leak, which I told you, which actually tries to get different records and by asking extended version request, and you will get all. So yeah, it's written in most modern language. It's called Perl, and you can find it on GitHub already, and it's published. So, and you can actually use it as protocol documentation because I've done most of the hard work looking for what bytes looks like and so on. And it's actually, I think it's just the tip of the iceberg. I just touched the tip of the iceberg, and I invite you to actually try the other things because the protocol is very easy, and someone who just want to learn new things, how to reverse the protocol, how to reverse the firmware, I think it's pretty cool to actually start something with this. And how you just say, this is just a basic usage, how you can say, okay, give me just the password it is. You can just reset the security record or without the security record and so on, without AS key and so on. And you can also dump all setup records if you want. And also you can do everything from once, right, if you're brave enough. So I know there is a lot of like young guys here who doesn't like Perl. So what I've done like nmap scripts, and in different ways. It can help you in different ways. First, what I've done is I wrote the service probe, so it will actually detect this protocol, and also like library implementation of this protocol. So if you find something new, you can just actually use this protocol, this library, and it will just save time to actually, you don't have to make a new protocol anyway. And what else is actually discovery in SC script. So if you just say ---- script Lantronics info, it will try to discover the devices. And this is how you actually use in scripts if you want to implement something new which you found out on this protocol. And this is still not in nmap trunk, but it's on the mailing list. It's publicly available on this link, so you can actually check it out yourself. And for the Metasploit, it's exploitation script, so you can actually dump records, do that leak trick, and get the password management to set and reset the simple password, and also to set and reset security records. So you have all 4 scripts to actually exploit these problems. And it's standard usage. You say like use auxiliary admin Lantronics dump records, you do show options, set parameters, and it will do it for you. And it's available at GitHub. It's also not part of the Metasploit master tree, but you can find it in my tree on the GitHub. Probably I will just make a pull request after the talk, so the guys, I hope they will include it. So this is something I've done actually these last 2 days. So you have it very fresh. And if you are still wondering why automatic scanning is bad for such devices, this is how, for example, the setup record 0 looks like if you try to scan it with vulnerability scanners or something. Yeah, you will just break the device. So you have to take care of such devices. And so the correct way is actually ask, if you're doing something like this, try to ask someone responsible. If there is something like embedded devices or some industrial control systems or any other utilities, it's always good to ask if they put something like this or what kind of network it is. It's actually good to actually just passively sniff. And then you can actually see what's happening on the network, and that's the good way actually to see the devices. And also some kind of good timing, not some aggressive ones, is also good. And if you identify some kind of port like this is open, that means you can play, right? And this is, I think I just really touched the tip of the iceberg, so I invite you to actually dig further, and you can play, right? And it's always good to check if it's still working, because such devices are really fragile and don't play too much. So what you can do, if you have something like this, and now you have like scripts to discover if you have, especially if you have those devices which I explained you before, they all fall in this category. So if you have some kind of alarms on the network, HVACs, pools, sprinklers, if you try to hack vacuum cleaners, they are usually like recommend Lantronics to put it inside. And yeah, embedded system, industrial system. So yeah, this is how actually the security of maybe all alarms are, right? And this is all what you can get. And with this tool, actually, what I found you about this protocol, you can always see this is actually hex dump direct from the tool. So you can actually see every time what command I've done, and this is the output directly from the tool hex dump. So you can get it how it looks in the protocol itself, right? So it's kind of guided thing. And yeah, what you want to actually do is really to have some kind of separate network for such things. And especially you can actually disable all, for example, SS, FE, 77 FE age, you can actually disable on the device and only enable it if you need to configure it via this way or do some kind of IP filtering and so on. And because there is also some other services which are problematic, like SNMP and Telnet, which are like plaintext protocols and so on, which have problems itself, right? So definitely you want such things to have, like disable it or tunnel it from VPN or something. Yeah, this is what I already told you. It's really tip of the iceberg. It's really simple if somebody wants to play. You're invited. I have a few dumps as well if you want to play more. And you can really, even if it's like simple passwords, if it have enhanced passwords, you can really go beyond it, beyond application. And you have like nmap scripts, Metasploit, and standalone tool which is called Lantronics Switchcraft on my GitHub for playing. And these are the recommendations I already told you. What I've done most of the protocol reversing and guessing and so on, so this is like 80% done. But I'm still working on the firmware. It's kind of work in progress, but if you want to join and to take over or something, I'm really enlightened to give you, because I have kids. And yeah, there's really new things to research, because I really think I just touched the tip of the iceberg, and you can really maybe start to play with such things, because I think it's not just one device, it's not just one Lantronics device, it's actually they just build it everywhere. You can really find it what I've showed you everywhere, because they just use like ready-made solution to just, so you can really find it if you try to scan for alarms, sprinkler systems, pool system, whatever, you can find what embedded system which controls something, maybe they have something like this. And now you have actually starting point to start digging more. Or to summary in this one, yeah, it's definitely triple facepalm. And this is acknowledgements and people who've done some previous work. It's good to actually mention them, and also my colleague which is doing like hardware stuff. And if you have some questions, maybe it's not right now the time. I will just show you just quickly how it works. So I have, can you see it? No, great. So I have such device here, and it asks for password, right? If I type, yeah, I can try like any good password on me. Root. No, I tried admin. So yeah. Right. So this is what I told you. You can like ask for password politely, and it will tell you like, okay, this password is test, right? This is simple password, but if I go and try to enter this simple password, it doesn't work. So that means the simple password and enhanced password is set. So that means I have to first reset the enhanced password, and then I can enter the simple password, which I know right now, right? And usually, sometimes you can guess from the simple password the enhanced password. So, in this time, for example, I want to just reset the security record.
Can you clear the screen so we can see it?
Sure. So, it's this one. So, I'm just resetting the security record right now. And it says successful. So now I reset the security record, but not the setup record, and that means I still have like this password test. So in this case, I can just write, and it is right. And now I can just also like, no.
Tile the window to the right so we can see.
Okay. Now I cannot connect, but this is what I'm telling you about. It's kind of fragile. But yeah, it's now once I entered here. So what I entered is like reset the security record, and this is once the security record is resetted, I have the simple password. I asked for the simple password, of course. I already asked it. But it didn't work. Once I resetted it, it works. So I could just enter this one and enter the system itself. So yeah, now.
And the standard partner menu, that's specific to the electronics behind the electronics?
No, this is the electronics itself. But now with this, you can actually have access to the serial port of this, because you can then configure like all the inputs from the serial. And now
You know what's on the other side.
Yeah, but now you have to talk with the serial port. And now it depends about the device what you have. But now you have access to the clean serial line. Before this, you cannot, right? It can have a like AES key or something, and you just cannot, right? Now you have like, and usually you don't have authentication on serial line. It depends. Some alarms have, some like systems and so on. But most of them like trust the AES key or something like this. But now the fun begins, right? Yeah, that's it. If there's any questions, please ask. This is my Twitter account. Ask me, and go and play. I think you will definitely find some of these devices, because it's much usual, and vendors don't want to implement their own stack, and that's actually a clever way. You don't want to have so much TCP/IP stacks vulnerable, right? And yeah.
So there's a separate port for doing the serial communication?
Yes. You can.
And if you know the AES key, you can sniff that and see how the electronics behind is actually.
Yes. You can actually not to just sniff the key. You can just reset the key, the AES key, and then.
But then the real operators will know, because it simply
Yeah,
doesn't
yeah,
work with that
yeah,
part, right?
yeah.
That's not a good idea.
Yeah.
So I want to keep the AES key as it is.
Yes. Yeah, and this is what you can do, of course. And I think it's quite interesting, because you can really find it in quite places. But you will not find it like Lantronix. You will find it like Bosch alarms, for example, or something like this, right? Yeah.
Did you scan the internet for device available?
Good question. Good question. Thanks. So the question was if I scan the internet for such devices. I didn't. What I'm doing is I started doing like looking at the binary firmware, and I found some interesting things. So I just want to have everything on a heap, and then scan with all these things, because there is other interesting things inside the firmware, which I cannot still, let's say, disclose, because I'm still working on it, and I suspect something, but I don't have it right now. But you can start playing. I can give you the firmwares. I can give you the all these things what I found so far. And if you are
And you
ready
said
to play,
it's only UDP?
it's UDP and TCP. But
It's
actually,
both.
yeah, it's both. You can find the UDP and TCP port. Yes. So yeah, you can use both ports. But the protocol is actually the same. So you just say connect TCP, send this, and it's same. So that's definitely, yeah, you can use Tor. And, yeah. So yeah, go and play. Any other question? Okay. Thank you.
Yeah.